All right. Our final review study guide for the final. The final is going to be some short essay questions, and there is going to be a piece of code. The code is attached to this document as well as to the final, so you have a copy of it to ask some questions about the code. But there's going to be a series of short questions, short essays to write. I will email the final out to everyone, and please email me your answers. For all the graduate students, do remember you are supposed to write me a one-page proposal, not some sort of formal document. It can be a text file, or you can use Word, on how you would go about making the blockchain faster, based on the papers that I sent out to you to read. And for the rest of you, for including the graduate students for the final, let's kind of run through these things. You should be able to explain what a zero knowledge proof is, and I put a link in there to Wikipedia. If you want to go read that, there is a nice explanation, but you ought to be able to give a layman's explanation of what a zero knowledge proof is and be aware of it. In one of the graduate or senior projects, they were actually unknowingly using a zero knowledge proof that could be worth vast amounts of money, and the way that they did it is based on some artificial intelligence and didn't even know that's what they were doing. But they basically built something very valuable for another purpose, and here they've got a zero knowledge proof in it. So understanding what you can do with zero knowledge proofs has some advantage, even if you don't know what the math is, knowing that this is a zero knowledge proof and this is the implications of what we're doing here. So be able to explain that. Explain what the acronym ZK-SNARK is. And I actually listed it right here in the study guide, but it's also explained in the Wikipedia article as well. And be able to walk through what that is. Okay. Be able to talk a little bit about when double entry accounting was invented, since one of those applications of blockchain is building more fraud-resistant accounting systems. You know, we talk a little bit about what was happening in Genoa, Italy, and explain how that relates to accounting and how accounting really hasn't had any changes in the past 500 years, at least not any technical changes. And this is the first technological change to come to accounting in that period. Explain to me why blockchain is important. And, you know, you have the internet where we copy everything and we circulate copies. I mean, if you display an image, you're doing a copy. If you're looking at a web page, it copies the HTML and renders it. So everything is based on copies. So if you have a concert ticket that you want to sell, you can't just turn around and sell it over the internet, because then you could sell it multiple times because everybody has a copy. There's no limitation on copying. Whereas with a blockchain, we can actually transfer digital assets and have limits on who has it and who doesn't and which one is real. So compare the value of today's internet to the value of an internet where all of those things that need authenticity, that need attestation to their authenticity, can be controlled with a blockchain. And that ability to generate attestation as to the ownership, how that affects other industries like real estate and titles and documents, and how you can prove date and time and authenticity with hashes and a blockchain of documents. So that's kind of the utility of what does the blockchain do and what does it do well. The converse of that is, what does the blockchain not do so well? Like, is it a good database? Is it fast? So there are some trade-offs. Be able to explain what a smart contract is. I mean, it's a name, but for us in software development, it's a program that runs. It's a small, simple program, generally speaking. Explain what mining is to a layman. And at this point, you've actually implemented mining, and what it's doing for mining isn't really that complicated. When you really got down to the bottom of it, it was, okay, do a hash, sign a block in a fashion where you can get these properties of Byzantine fault tolerance. And the algorithm itself is pretty simple, so be able to explain that, because we have all these people running around in the world saying, oh, they're doing mining, whatever that is. Explain it to them. Know what the good properties of a blockchain are, like the immutability of data and why that's important. The distribution of data between different nodes and what you can do with distributed data. The verifiability of past data, that's kind of part of the immutability, but how does a hash protect the blocks in a blockchain so that somebody can't come in and change values? The distribution of sources of trust. Why do we trust that a blockchain actually has accurate data in it? What property does it have that gives it that? And, the other properties of a blockchain. It's the slowest database around and the most expensive. Why would we even bother using it? But also, it is the slowest database around. It's not just, the business person comes to you and says, oh, let's implement it on the blockchain because that's a database. And therefore, that's exactly the same as Postgres. It's a database. Be able to explain what the differences are. One of the most important things is, how does a blockchain create trust between non-trusting parties? Because, that trust between non-trusting parties is a critical piece of what blockchain does. And this strikes at the heart of what is Byzantine fault tolerance. And when you understand Byzantine fault tolerance, you understand how it creates trust, because everyone has the same result. So when everyone has and agrees to the same result, we trust what that result is. It doesn't mean that the result is necessarily perfect or accurate, but at least we have achieved a consistent result. And be able to explain why the blockchain is the most expensive database. And we talk a lot about Ethereum having 12,000 nodes. If you had to go update 11,000 computers, that would cost a lot. I mean, it's not like you're updating one, you're doing it 11,000 times. If you're doing that all day long and you have to pay for some of the overhead of all day long, every day, 7 days a week, that's why it costs so much. Answer the question, why is it so slow? Probably one of the biggest reasons why it's so slow is that we are distributing the data between all these computers. Now, the fact that they all agree and they all have the same data and it's distributed means we are paying for tremendous resilience in this network. And if 1,000 of the computers got destroyed in a flood because they were all in one location, the network still continues. This doesn't affect it may perform slightly differently in a mathematical sense, but to the outside user, no change has occurred. Probably one of the most important things is that you be able to explain what is the Byzantine generals problem and how proof of work solves it, how Honey Badger solves the Byzantine generals problem. So that's important. Be able to explain, at least at a high level, what is a threshold ECDSA key generation, what is a signature, and what is ECDSA, elliptic curve digital signature algorithm. Why does it protect your value in a system to have a digital signature? And what proof do we have that these digital signatures are actually working? That, somebody can't come in and just forge a signature and the system will accept it. So those are kind of the non-coding things, and that is most of the test. A quarter of the test has to do with looking at this document registry contract, and it's what it does, and really those questions are what I'm going to ask. When is the constructor run? Who can call the functions? What's the criteria for calling different functions? And I'm going to ask you about what a couple of the functions do in the contract. And the code is right there. This is basically straight from your homework, so that you've got a contract to look at. It's in Solidity, and it's my solution to the document signature Solidity problem. So, unlike most finals, okay, if you've got questions, ask. Okay, I'll remind you of my phone number. Message me. I will be around all week long. And my number is 720-209-7888. That's 720-209-7888. Message me. We'll work through it. It's not illegitimate to say, ask any questions you want about this, and let's work through it. The goal here is, as always, to learn more fun stuff. So, in as much as we can learn from the final, I would prefer to see that and give you a good grade with lots of questions than you have it, fill it in, and not learn anything. So ask me, we'll work it out. We'll get together on Zoom, we'll figure out what's going on. I will point out that I am having some trouble with the grading software. This won't affect your grade. I have all of your grades in a spreadsheet at this point, and I will be calculating it. Most of you are doing really well in the class, so don't be panicky about your grades. You're going to do just fine. The final is not hard. It is a series of short answer questions and the questions about the code. It's 400 points. That's kind of the material I wanted to cover about the final and the final review. If you have specific questions, contact me before the final comes out or during the final. I will email out the final as soon as I get done touching up some things on it, probably late tonight. I need to have it back by Friday at midnight. I believe that is Friday the 15th at midnight. I'd prefer if you got it done sooner so that I have time to grade it, because I do have to get in my grades. But if it gets here at 11:59 on Friday night, that's no penalty off, no loss. I'll still be a happy camper. What else? Some of you are graduating. Yes. And, this is maybe even a required class for you to graduate. I do have fairly good news on that front. I have been paying attention to hiring. There is, if you want to stay in Wyoming, there is way more remote hiring in the computer field going on than ever before. There are lots of people that are still building computer things and software, and they are not slowing down. Seriously, think about it this way. What is the thing that is keeping the world going at this point? Is it things like Zoom and Google Meeting? We are running the world on software today, and it is the most critical piece of infrastructure in existence today, is all of these things like screen sharing and communication and the ability to work at home. I see that a vast number of people are working at home, including me at the moment. And this is going to be a big structural change. I don't think this is going to be going to go away. The working at home folks are way more common. When they surveyed chief financial officers, CFOs, in large companies, 94% of them said that they were going to look in the future at having far less office space and having more of their company work at home, just for the simple reason that it's working. When they measure productivity of people working at home, it's consistently higher. And when they look at all sorts of things like expenses, it is cheaper to have people work at home and you get better results than when they work in an office. For one thing, you cut out commuting, and commuting is both a huge cost and terrible for people, just absolutely terrible. If you commute more than an hour each way to work, the rate of divorces in families that do that is almost twice as high as those that commute less than 10 minutes each way to work. So commuting is just really bad for everyone. So, this is by and large, I think, a good thing. Now, in terms of are there jobs out there to be had? Is the world come to a halt? I don't think so. Every month, Y Combinator has a who's hiring, and it's basically a job listing once a month. And you look at the number of computer technical people being hired, has not really dropped. I think you're going to see in the very short term that there are more people that are out of some jobs because of the economy right now. But it's going to be very short lived, and there are still a lot of people hiring in the computer field. It's a bump in the road. It's not, the end of the road. You're driving along the road, and by golly, there's a pothole, and your tire goes ka-thunk, thunk. You don't stop and quit driving and go, the world came to an end. I hit a pothole. You go, oh, that was painful. Let's move on in life. And that's certainly what I'm seeing is we've hit a pothole and things are proceeding onward. So that's kind of the message I want to leave you with is things look hopeful and good. And I hope all of you have a wonderful summer. I will very much miss seeing all of you in class. And let's touch bases over the final if you have any questions. All right, catch you later.